7.4 Simulations. In this section, we are going to simulate outcomes that are equally likely. We're going to create a simulation, which is an experiment that is designed to reproduce the conditions of a situation or process. And we're going to use this simulation to find probability. So we have a situation where we have a dog and the dog has 3 puppies. Well, each gender of the puppy is equally likely. Okay, so we are going to run a simulation or design a simulation involving 20 trials so that we can try to model the genders of the puppies and use this simulation to find the experimental probability that all 3 puppies are going to be male. Okay, so we're going to run a simulation and we're going to use a coin. And the coin has 2 sides. And so we're going to have the heads mean that it's a male, and the tails mean that it's a female. Okay, so we're going to flip a coin 20 times. Actually, we're going to flip 3 coins because we have 3 puppies, right? We're going to flip 3 coins 20 times, and we're going to record if it lands as heads or tails. Okay, so these are going to be our trials. So for instance, here, trial 1, we flipped 3 coins and we got heads, tails, heads. Okay, if we trial 2, we flipped 3 coins and we got heads, tails, tails, right? Okay, so this is our simulation of a mom dog having 3 puppies 20 different times. Okay, obviously we're not going to do that in real life, so that's why we create a simulation. Okay, so now we want to calculate the experimental probability that all 3 puppies are males. Well, looking at our table, we know that males are heads, and there's only 2 occurrences of that, right? And how many trials did we do? We did 20 total. So this simplifies down to 1/10, which is the same as 10%. So the experimental probability of having all 3 puppies be males is 10%. Okay? All right. We can also simulate outcomes that are not equally likely. And when we do this, we usually use a random number generator. Okay. And we will, since we have this situation here where we're going to try to win a board game and we're going to win a card game, right? So here's the board game and here's the card game. Okay. Well, we have 60% chance of winning a board game and only 20% chance of winning a card game. So we're going to use a 2-digit number to help us create some outcomes. Okay? So when we have a 2-digit number, a number can range from 0 to 9. And how many numbers is that? That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 of those total, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits total, right? So if we know that there's a 60% chance of winning a board game, we're going to assign the numbers 1 through 6 to mean that we won the board game, right? Because 1 through 6, that's 6 numbers out of 10. That gives us 60%, right? Now, we're going to also assign the numbers 1 through 2 to be what? To be our winning the card game. Because 2 out of 10 numbers gives us 20%. We could have chose any 2 numbers, but we're going to choose 1 through 6 for winning the board game. That means we won it. And 1 through 2 to mean that we won the card game. All right. So the tens digit is going to represent our board game, and our ones digit is going to represent our card game. This looks a little messy, but so what we did is we randomly create numbers and we're going to look. Now we need to know if we want to win both games. To win both games, the first digit must be a 1 through a 6, and the second digit must be a 1 or a 2. Okay, so let's look. Here's 1. I think they circled all of them for us, right? So how many times in our simulation did we win both games? 1, 2, 3, 4, 5, 6, 7 times. And how many trials did we ran? We ran 50. So 7 of the 50 times, we won both the board game and the card game. And 7 over 50 is approximately 14%. So 14% of the time, we won both games. Okay, I know that's a little confusing, but we'll go over it again in class. All right, now it's time for you to write in your notes. There is actually only one fill in the blank to write. And now you have just one practice problem to do. All right, with your practice problem, we are talking about each school year, we have a 40% chance that the weather is going to cause school to be canceled. Okay. And we want to estimate the probability that weather causes a cancellation at least 3 years in a row in the next 4 years. Okay. So we're looking at 4 years, right? And each year we want to see, did weather cause school to be canceled? Okay, so we need to have 4-digit numbers, right? 1, 2, 3, 4. So if we have 4-digit numbers, each digit represents the year. So the first year, we need, in order for school to be canceled in the first year, remember it's 40% chance. And if we're using the numbers 0 to 9, or 1 to, well, I guess 0 to 9 is fine. Then we need 40% of those numbers, right? Which is 1 through 4. 1, 2, 3, 4, that's 4 numbers. So 4 over 10, that gives us 40%. So we're going to say that if a digit is 1 through 4, that means that they had a cancellation. Okay, so we need to look at all our different digits in our number, right? We need to look at each place, and we need a number 1 through 4 to be 3 years in a row, right? So it could be here, 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 and then not there. It could be not here, but here, here, here. I think that's it, right? Okay, so they already did this for us, right? Here we see this meets the criteria because 1, 4, 1, those are all below between 1 and 4. 1, 4, 2, all between 1 and 4. 2, 4, 2, all between 1 and 4. 3, 2, 3, all between 1 and 4. There are no other numbers that meet that criteria. Okay, so how many times did it happen in our simulation? 1, 2, 3, 4 times. And how many trials did we run? 50. So 2 over 25, and 2 over 25 is the same as about 0.8, which is the same as 80. 0.08, Mrs. Tenery, which is the same as about 8%. So your answer should be 8%. And that is the end of 7.4. But remember, we'll go over this one a little more in detail in class since it is a short section, but a little confusing.